So what are sets and how do we represent them? That's our lesson for today. Stay tuned. Okay, so our lesson for today is about sets and how do we use notations to describe sets. But first, what are sets? So sets are a collection of objects of any sort. One example is a set of colors in a box of crayons. So let's say you have 8 crayons in a box. So all the colors in that box of crayons, we can call that as a set of colors. Another example is a set of numbers from 1 to 5. So that's 1, 2, 3, 4, and 5. That's a set. Or we can say that a set of cards in a deck with red colors, just those with red colors. Okay, so sets are a collection of objects of any sort, of anything. Now we use capital letters when we name sets. So for example, capital letter A, and then we have 2 curly brackets, and inside those curly brackets says the colors in a box of crayons. So meaning set A, capital A, is a set of colors in a box of a set B, capital letter B, and it contains 1, 2, 3, 4, 5. Another example is a set C, capital letter C, which contains cards in a deck with red colors. Okay, I hope that's clear. Now, members of a set are called elements, and we use small letters when we name elements. Okay, so here for example we have set A, capital letter A, and its elements are small a, small b, small c, small d, and small e. Another example is set B, capital letter B, which contains elements x, y, and z. Okay, to indicate membership in a set, we use the symbol epsilon. And then, to indicate non-membership, we just basically put a slash on the epsilon sign. So here, assuming we have 2 sets here, set A, which contains numbers 1, 2, 3, 4, and 5, and set B, which contains A, B, C, D, and E, we can say that 2 is a member of set A, or in symbol, in notation, we write that as 2 epsilon capital A. And then here on the second one, F is not a member of set B, and in notation form we write that as F, then the epsilon sign with a slash, capital letter B. Okay, I hope that's clear. Now there are sets that are finite, and then there are sets that are infinite. So what's the difference? A set is said to be finite if we can list down all its elements. Example, set A. We can list down the members of set A, and it's 1, 2, 3, 4, and 5. It's very clear. They are finite. How about the infinite sets? An infinite set, a set is infinite if we cannot list down all its elements. One example is set A, wherein A contains all the points in a plane. There are a lot of points in the plane. It's infinite, therefore we cannot list it down. Another example is set B, and it's X. It contains X such that X are all points in a line segment. So it's similar to set A. By the way, the bar symbol, it means such that. Okay? Now, what about universal set, subset, and null set? Okay. A universal set is a set of all elements under consideration, and we use, as a symbol, we use the capital letter U to describe it. So one example is of a universal set is an alphabets of the English language. So basically, all the letters A, B, C, so on and so forth up to Z are members of the universal set for this particular example. Another example, a universal set that contains all the integers from 1 to 100. So that's 1, 2, 3, 4, 5, so on and so forth up to 100. They are all members of the universal set U. Okay? Now, a subset is a set belonging to the universal set. So for example, let's say I want to pick letters C, D, E, F, G, H, I, J up to J. So, and then I will call that group as set A. So meaning set A is a subset of the universal set. So a subset is a set belonging to the universal set. What about the null set? The null set, as denoted by this symbol /0, it's not actually phi, it's /0, is a set that contains no element. By the way, no element is not equal to 0. A 0 is an element. 0 is not equal to null set. 0 is between -1 and 1. Null set is empty. It's nothing. Okay? That's a difference. And with that definition of null set is always a subset of any set of all sets. So for example, we have set A that contains 1, 2, and 3. It's actually 1, 2, 3, and nothing. So that's why null set is a subset of all sets. Anyway, as you can see here, I have a green rectangle here representing our universal set. So all the elements inside the green rectangle are all members of the universal set. And then I have this red circle which represents set A. So with this, we can say that all the elements of A are members also of the universal set because A is a subset of the universal set. And now you can see here a triangle. Here, all the elements of the triangle represented by set B are also members of the universal set, but they are not members of set A. Okay, so on our next lesson, we will discuss more about this. Okay, how do we describe a set? In describing a set, we either use the rule method or the roster method. So what are those? In the roster method, we basically list down all the elements inside the bracket. Okay? Here's an example. We have set A, and then we list down all the elements of set A in a bracket, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the numbers 1 to 10 are the elements of set A. And we describe set A by listing down all the roster. That's why it's called the roster method. The other method, the rule method, basically we enclose in braces a descriptive phrase and agreeing that those objects and only those objects are elements of the set. So using the same example on the roster method, we can say that set A and then two curly brackets, inside the two curly brackets we write integers from 1 to 10. So basically we describe the elements of set A and the description is integers from 1 to 10. Okay? So let's have some exercises. On this exercise, we will use the rule and roster methods to describe the following sets. The first one is this. The fraction whose numerator is 1 and whose denominator is a counting number less than 10. So what are the givens? The numerator is 1 and the denominator is x, and x is from 1 to less than 10, ergo 9. So x is from 1 to 9. So for the rule method, we can say that, we can write that as 1 divided by x, 1 over x, such that x is a counting number between 1 to 9. Okay? And on the roster method, we basically list down everything. So that's 1, 1/2, 1/3, 1/4, 1/5, 1/6, 1/7, 1/8, and then 1/9. Okay? Now, second example. Counting numbers which are multiples of 2 and less than 20. What are the givens? The numbers are multiples of 2 or 2x. And numbers are less than 20. It should be less than 20. Therefore, x is less than 10 or x is from 1 to 9. Using the rule method, we can write this as 2x such that x is a counting number between 1 to 9. Or in the roster method, we can write this as 2, 4, 6, 8, 10, 12, 14, 16, and 18. Okay? So that's our lesson for today. I hope you guys learned something. Next episode, we will talk about subsets and counting. So please like this video and subscribe to our channel and hit that bell button as well, so you will be notified each time we publish a new video. Have a great day. Bye-bye.